Okay, in example 411, we're asked to draw a cartoon representation of f of x equals e to the x and f inverse of x equals ln of x. And we've done this before. The idea is that you have a function and its inverse. So if this is the first function, it'd be like e to the x, and this is its inverse, ln of x. And the idea is that when you feed x into e, you get e to the x out. And then when you feed e to the x into its inverse, you should just get x back. So this is ln of e to the x is equal to x. And I think the notation is kind of confusing because you have an x in the exponent. The idea is the exact same as when we did f inverse of f of x. The whole idea is that f inverse is supposed to undo whatever f of x does. And we could have done the same thing. We could have plugged in of x into ln and then plug that into e, and you should get the same thing back when you're all done. So this is ln of x. When you plug that into e, you get e to the ln of x. But again, that should just be x, because e undoes whatever ln of x does. So this is like f inverse of x in this case. So that's the sole purpose of the natural log function, is to undo the exponential function, the natural exponential function e to the x. So it's the inverse, it undoes whatever e to the x does.